In part 2 of this lesson, we have two more questions related to quantum numbers. In the first question, we're asked, these sets of quantum numbers are each supposed to specify an orbital. One set, however, is wrong, erroneous. Which one and why? So let's go through all four of these options and see which one is wrong. In part 1, we learned how to calculate L. Remember that L stands for the orbital angular momentum, and that's found by taking n and subtracting it by 1. So in our case here, n is equal to 3, and if I subtract that by 1, I end up with L is equal to 2. So far, this part and this part make sense. And if L is equal to 2, when L is 0, you should have a magnetic quantum number that's equal to 0, and that's the case here, m sub L. So A is correct. In part B, we have n is equal to 2, L is equal to 1. That makes sense. It's possible that L can be equal to 1. And when L is equal to 1, you'll have a magnetic quantum number that's either -1, 0, and 1. So this also makes sense. In question C, n is equal to 1, L is equal to 0. That's possible. And as in question A, you can have an m sub L equal to 0. So therefore we can assume that D is incorrect, and just to be exact, let's learn why. N is equal to 4 minus 1, that's L is equal to 3, so you can have an L value of 1, that part is right. But if you have an L value of 1, like I mentioned in part B, you can only have the following magnetic quantum numbers. Over here we have -2, so this suggests that L should be 2 instead. Let's move on to a similar question. Question 2, which reads, each of the following sets of quantum numbers is supposed to specify an orbital. However, each set contains one quantum number that is not allowed. Replace the quantum number that is not allowed with one that is. So we're doing the exact same thing as question 1. Let's start with A. Right away, you have n is equal to 3 and L is equal to 3. There's a relationship between L and n, and it's this. L is equal to n minus 1. These two don't match, so this should be a 2. This part is correct. Moving on to part B, this matches, but this -2 is outside the range. The range for L1 is between -1, 0, and 1. So we can change this to 1, and that would work. Finally, in question C, n is equal to 1 and L is equal to 1. That's impossible. This should be 0, and if that's 0, this is correct. And there you have it. Two more examples on quantum numbers.